class, today we're going to talk about parametric curve calculus. So it's surely going to depend on what we did last time, talking about what are parametric curves. And just remember, parametric curves were another way for us basically to describe a curve in 2D, or higher dimensions for that matter, where each coordinate is a function of some other parameter. So we thought about x and y being functions of some parameter t, where we thought about t being something like time. So if we were just walking around on a 2D plane or in the xy plane, as we move around, our x and y locations will change with respect to time. So it's kind of how we've been thinking about parametric curves. So let's just check out what we're going to do today. So in particular today, like I said before, we're going to go over the basics of some parametric curve calculus. And just to remind ourselves where we're coming from, a parametric curve we use to describe curves that basically failed the vertical line test. So this is kind of how we motivated why parametric curves might be a useful thing to start thinking about, especially since we could start defining curves or start investigating curves. So things like spirals and other complicated curve shapes like that. And we briefly mentioned earlier in this video that a parametric curve, at least in 2D, is where both the x-coordinate and y-coordinate are functions of a third parameter. And we've been thinking about that third parameter as being something like time. It doesn't have to be, though. So for example, the notation for a parametric curve is given in the standard kind of point notation on the xy plane, except x and y's are functions of that parameter t. So let's check out what we're going to do today. So the basics of parametric curve calculus that we're going to begin with are calculating the slope along a parametric curve. So let's just kind of draw some example for this. So if we actually try to investigate something like a spiral, again, parametric curves live on the xy plane. If we're investigating something like a spiral, we might ask ourselves, you know what? At some point along that curve, what is the slope? And that's the first thing we're going to investigate. And just as a spoiler, we're still going to be looking for a slope that looks like a change in y over change in x or rise over run. Next, we're going to set our sights on finding the concavity of a curve. And concavity, if you remember from Calc A, was synonymous with computing second derivatives. So we're still actually going to try and compute a second derivative of y with respect to x. Now, what's going to feel a little different about these as compared to Calc A is, remember, we don't have a function y that's a function of x. X and y are individual functions of that parameter t. The next thing we're going to do is basically ask ourselves, how can we find a tangent line to any point along the curve? So this kind of goes back to that same line I drew before. If we care about this point along the curve, we could compute, hey, what is this tangent line to that very point? Next, we're going to think about what are the horizontal and vertical tangents to a parametric curve. And as you remember from Calc A, well, a horizontal tangent is whenever the slope equals 0. And a vertical tangent, well, that's going to be whenever the slope looks like it's infinite, plus or minus infinity. And the next thing we're going to do is kind of go back to integrals and start asking ourselves, how can we extend the idea of calculating a length of a curve? How can we extend that to a parametric setting? So we're going to derive the formula for finding the length of a curve in a parameterized setting. And similarly, we're going to figure out how to compute the area under a parametric curve. In both of these integral applications, we're actually going to start off with what we know from Calc B earlier in the semester on what is the area under a curve, what is the length of a curve, and we're going to extend those notions into parameterized settings. So that's what we're going to do today. Please check out the following videos. See you soon.